Hello, good afternoon. My name is Kelvin Enuma and my teammates call me Paniel, and I'm the technical manager at Rivents Lab. So what Rivents Lab has been able to do through the help of NGVentilators is to come up with a prototype for a ventilator, mechanical ventilator to help corona patients, and we have named this ventilator Vent 1.0. So simply, this ventilator is able to serve the patient for 3 to 4 hours on battery backup, and we also have included a bit of information technology by using the Android device to also control the ventilator. For us, this is a very important step, because considering the number of patients that we have both in Nigeria and worldwide, we think this ventilator is going to help to sort of reduce, the death rate, because we know how difficult, the absence of a ventilator to a corona patient can be. And I'm happy that this opportunity was given to us, and of course we need a lot of help to get this out there to those that need it. One of the things that we are going to be doing in this video is to do a brief demonstration on how the system works, so you get to see the different parts of the ventilator and how it's being controlled, the functionalities basically. Thank you.
So turning on Vent 1.0, an initialization process takes place. So this process means that it's waiting for a signal, and this signal in the form of a form of breath from the patient, because by default the system runs on sensor mode, which requires the patient to try to take in oxygen, and then the system begins. So on that process, the motor compresses the bag, and then the bag continually supplies oxygen to the patient. Now there is a form of fail-safe condition that is attached inside of the system, such that after 10 seconds, if the patient is weak and can no longer try his best to take in oxygen, the system switches from sensor mode to time mode. Now in time mode, variables have been set already. So variables like the respiratory rate, the FIU, the tidal volume, and the I ratio, those variables are already set. And then when it switches to time mode, this now controls the motor and then supplies oxygen to the patient. But this time around, the patient no longer has control over how the motor supplies the oxygen. On the system, we have an LCD display screen which shows the variables, that's the parameters, and also shows the mode the system is currently in. And we also have 3 push buttons which are supposed to control those variables. So one push button is supposed to increase the variable, another is to decrease, and then the last is to lock down the value, which we call a set button. Now we also have a form of buzzer that indicates when the system has switched from one mode to the other, and then inside of the system we have sensors, pressure sensors, which help to monitor when the patient is about to take in oxygen and then supply the oxygen to the patient. Now for in the time mode, what happens is that when the doctor changes those variables, just like my other partner said, that there's an app that can also control. So the LCD displays what also shows in the phone. And then for the motor, we have a rack and pinion gear which is attached to it, which converts the rotary motion of the motor to a linear function and then compresses the bag to supply oxygen to the patient.
For ease of access, an Android app was also developed to aid the doctors to monitor the values and change parameters. So with this app, you can see at real time the current values, the parameters that the ventilator uses to operate, and the current mode, whether it's in time mode or it's in sensor mode. And from there you can easily change the parameters, and you can switch from time mode to sensor mode, change the respiratory rate, change the tidal volume, also change the I ratio. And there's a feature we also want to include in the app, which will include the history and the log of every action that is taken in the app. So everything that happens to the ventilator, you can go back to the history and view the patient's activity through this app.
Vent 1.0 has 3 compartments, which are the power compartment, the magazine compartment, and the control compartment. The power compartment basically carries the battery and the battery charger inside of it, while the mechanism compartment carries or houses the mechanism, which produces a linear function to compress the ample bag and also houses the ample bag in it, while the control compartment carries the ICs and all other functions that are used to control the movements of the mechanism. The major materials used in producing this particular machine are the HGF plywood, which was used in producing or making a frame that houses the ample bag and the mechanism, while the MDF plywood, which are used in covering the body of the machine, and then the angle rod to build up the frame in order to carry the weight of the battery and the machine.
Wait now, Xavier, how is he doing here? So it is sweet, Xavier. Xavier, this thing was made for you.